things. We ended up our notes over here talking about the DI, the DO equation, which is trying to calculate where your focal point or your focal length is going to be. Where is it going to be? So we use this in eye doctors all the time. They are trying to make sure that if you do the eye exam and you're reading the letters on the chart and you're not reading them clearly, well, that's because your focal distance or your focal point, which should be connected to your retina, is not at that correct location. There could be different reasons. It could be your eye muscles are weak. It could be you have astigmatism. Astigmatism means that your lens inside of your eye is misshapen. It's shaped more like a football than a round lens. Remember those round lenses we passed around and we were looking at? So your eye should have a round lens, and it should be convex lens. Well, some of our lenses are actually shaped kind of like football. We call that stigmatism. And so that causes this number right here to be off. When this number is off, then our vision is blurry. We can't see very well. Now, some of us are a little bit different. Some of us cannot see far. Some of us cannot see close up, right? We call that nearsighted and farsighted. And that's what the next page is going to cover a little bit of. Now, I am telling you that I'm going to skip this part. It's just literally reading the difference between what we call a real image and a virtual image. That's all it is. Okay? Now, let's just make it really simple or make sure that we understand whether it's real or whether it's virtual, it's still fake. Okay? It's not the real object. Okay? If it's a real image or a virtual image, they're both fake. They're not the actual object, okay? But there's a difference on how the reflection is going to occur. And so that's what those are. And then I went ahead and I put it into a chart form to really try to simplify. I think charts are really easier to read. Cut away all of those words, the, a, and, right? And let's just get to the simple stuff. That's what that is. Now, I'm going to go ahead and I'm going to scroll down here, though, to talk about the word magnification. There is a question on the test, and it's really super easy cheesy regarding magnification. So I want to go here. Then I want to talk about the actual eyeball itself, and then I'm going to get into the, into the quiz next. So looking at this part of our notes right here, it says magnification. Now, don't get me wrong, this is pretty easy cheesy because all of us have probably used and played with a magnifying glass, all right? Most of us have. It says here that magnification is when the image of an object changes in size, right? It changes in size. Am I making it? But believe it or not, you can change the size to not only a larger size, which most of us are familiar with that, right? If we get a magnifying glass, we can enlarge the image. Or if you're looking through a microscope, you're looking at the bacteria that is so tiny, but yet now you can see the bacteria because you magnified it. Believe it or not only larger, but smaller. Okay, magnification not only means for it to get larger, it also means for it to get smaller, okay? It says over here, it depends. If I've got greater than 1 magnification, then that image is going to be larger. It's going to get bigger. If my magnification is less than 1, then the magnification of that image is going to become smaller. Pretty easy cheesy. Let me give you an example. I'm going to say example over here. For an example, if they tell me that the magnification is 1.42 M, capital M for magnification, then that means that the image got larger. Makes sense. Greater than 1, 1.42 magnification. If they tell me on the test that the magnification became or is 0.42 M, well, then that means that the image became smaller. Pretty easy cheesy, I feel like. We got that one, okay? It says here, now, when we're talking about lenses, Remember when we were playing with those lenses, we had concave and convex lenses, and we had concave and convex mirrors. Now, talking specifically about lenses, it says here, use both types of lenses, which we did. It says to look at some print. So I had asked you, hey, use those lenses in front of your camera on your cell phone, see what it looks like on taking a picture, look at the actual notes, play with the lenses. Hopefully you did. Now, a convex lens over here, it says causes the converging, causes a plus magnification. That is the shortcut to say larger. One more time. Plus magnification is the shortcut to say larger. Convex lenses causes an image to have a larger magnification, but yet concave causes it to have a quote unquote, we use the negative as a quick symbol to say that it just got smaller. Again, easy cheesy. Greater than one number, less than one number. I think that's pretty easy cheesy. Turn the page when you're ready. We're going to do a little bit more on the next page, and then I'll leave you alone when it comes to notes, because we can fill that last part in over magnifying glasses. The cow eye. I did not forget about the cow eye. We absolutely will look at the cow eye next week. The problem is we do have a test tomorrow, and so we need to kind of push forward so that way we have the material, and then we can cut open the cow eyes. I got 3 buckets in my office of cow eyes. I opened them up, and they're good and juicy. What do I mean by that? They're not like deep, like smushed in and like, you know, tiny. Nope, they're nice and big cow eyes. So we have those for next week. Again, if you don't feel comfortable doing it, then maybe have somebody else and you just look over their shoulders. I have gloves for you for next week when we do this. It says here, some of us have some vision problems. Some of us don't. You're great if you don't. Unfortunately, some of us are going to be considered what we call farsighted. You've got farsightedness. But some of us are nearsightedness. Myopia and hyperopia. It says here, for the farsighted person, if you know if you're farsighted or nearsighted, it says that farsighted person, distant objects are seen clearly, but it's near objects that are nearby you, kind of like reading, are blurred. You know, trying to read a book. I can read the sign, I can see the red light, green light changing, but I can't, it's a little blurry reading the book. It's blurry seeing close up. That's a farsighted person. It says here, this is caused when an eye produces a focal image. Remember that focal length, that focal distance? That focal image of a nearby object, but the image position is located or positioned behind the retina. And I know that I've used that word retina quite often. That retina, when we open up the cow eye, is going to be like this nerve. It's a nerve that goes from the back of the eye up to your brain. That is going to tell your brain what you are seeing. Now, this means that this person, their actual image is being produced behind the retina. This is the retina right here, but look, that's where it's being produced, behind the retina. And so they're not seeing a clear image. They can't produce a clear image to go to their brain. It's blurry. Okay? So in this situation, we're going to have to do something. We're going to have to wear glasses, whether it's just for reading glasses. Some people, they're like, oh, I just need reading glasses, or I just need it to read. I can see when I drive, I can see when I play sports, but when I do my homework, I kind of need my glasses. If you're that person, then there's a good chance that you correct your vision by putting on glasses that are converging. Oh, what type of lens is that? Converging. We should know because we have a test tomorrow. But just in case if you don't know, a converging lens is going to be convex. Oops, convex. Okay. So now, here's my eye, same person. This, they have the problem they can't see. They're making poor grades in class. The teacher says that, you know, they're reading like over here or something. So now they put on glasses. Do you see it right here? And they're able to correct their vision, and now the focal point is back here up against the retina. The retina can detect the image. When the image is produced on the retina, it is inverted upside down. It is upside down. Your brain, by the time it goes from upside down and it touches your nerve in the back of your brain, which is that retina, it takes it to your brain and your brain flips it right side up. Okay, so now you have these glasses, you're able to see. Now for nearsighted people, I feel like I'm just blind practically, and I got horrible vision. But nearsighted people are the myopia, that where near objects are seen clearly, but distant objects are not seen clearly. It's hard, it's difficult to see far out, far away. So it says here, this is caused in, for this case, light from that distant object is focused in front. That image, remember that image? That focal point is located in front, right here. Your retina should be back here. It should be touching the back of your eyeball, the image. But the image is produced over here. So again, you're not seeing it very clearly. You're going to have to put on glasses. And you're going to put on glasses that cause a diverging of light. Ooh. Well, which type is diverging? Which type of lens? There you go. Concave. Concave. And can you tell this one right here where it's like it's sunken in the middle? Concave. Okay? So I just wanted to go over that part because I'm sure you can write it down. I just wanted to say it. Hopefully it sinks into your head a little bit. There are a couple of questions, but it's so much neater to actually get an eyeball and cut an eyeball open in your hands. There's nothing like getting something's eye in your hand, and yes, Noah, and cutting into it and tearing it apart. I'm sorry. This last part here, Noah, I'm going to let you finish that because Noah's disappointed in me. I'm sorry, Noah. I apologize. Last part. And then we are good for the day. We're going to talk about that quiz. You probably have the quiz, right? You can either print it out, or some students, they just do it like on their laptop or whatever, and they just circle it like with their finger or your little pen or whatever. Perfectly fine. I had one student go and just highlight the sections that they wanted. That's perfectly good, as long as I'm able to read it, okay? So as long as I can read it, but let's go over this quiz right here. Some of these questions you're going to see again, specifically the math questions. There's about 3 or 4 math questions that are straight out of our test. I always do that. I just go and get our actual test, and I just pull those questions and slap them into our quiz. First, though, let's go ahead and take a glance at this part with our true and false questions just to make sure. It says here, electromagnetic waves require a medium. They require a medium? Absolutely false. They don't require a medium. They could travel through a medium, but they don't require one. Just in case, if you like, you know, Google search Gemini, the answers, Chris, you know, and you didn't read it on your own, and you AI'd all of this, Chris, let's make sure we got it right and we understand it. Just, I really don't know if he cheated or not. You know, he's on your team. He doesn't cheat then. He had to sign a contract. Right. Whoa. Noah, you're just a good person. You can't help that. The speed of light in a vacuum is about 3 times 10 to the 8th power. Not only is that true, but don't forget, we also consider that to be the same speed as it passes through our atmosphere or air. Just in case, I like to toss in extra notes as a reminder. Number 3 says that radio waves have a higher frequency than gamma rays on the electromagnetic spectrum. Absolutely false. Number 4, the photoelectric effect supports the wave theory. No, not the wave theory. What does it support? That photons are like solid particles. Remember Einstein came up with that, but Sir Isaac Newton was the first person to say that light is like a particle, okay? Then Einstein came along with the photoelectric effect. Next part over here, number 5, correct answer number 5 is true. When light travels from a less dense medium to a more dense medium, it is going to bend towards the normal line. I guarantee you're going to see that question again. The next one, number 6, a concave mirror, please make sure you double check between the word mirror and lens, is also, it says over here, known as converging mirror because it reflects parallel rays towards the focal point. Correct answer for number 6 is true. Number 7 is a virtual image can be projected onto a screen. Wrong. Not a virtual image, and it's going to be a real image. We call those holograms. Some people they do hologram concerts now. Obviously, it's not the real person, right? Next one, number 8. Number 8 says the law of reflection states that the angle of incidence equals the angle of reflection. Absolutely, everybody should have got that one true. Guaranteed test question, right? The last 2 over here are both false. All right, when you're ready, let's turn the page. Number 9 and number 10 is false. The next part was fill in the blank, right? So using your notes and possibly maybe the internet as a resource, not cheating, resource. Hopefully you were able to fill this stuff in. The blank theory, first thing is there's 2 theories we talked about. We talked about light acting like a wave or light acting like a particle where it hits something. So there are 2 theories, remember. But finally, right now, we considered light to be a dual nature. We finally said we don't want to argue no more. We don't want to fight. Let's stop battling each other. Let's call light a dual nature. But the correct answer here is that the blank theory of light, it says proposed by Einstein, explains the photoelectric effect by treating light as particles called photons. All right, so there's a couple of answers I will give you over here. Particle theory, quantum theory, are pretty much those 2 answers. Particles, but some of us probably use the internet, and the internet probably gave you the quantum part. But we use the word particle, right? Like it's like a hard object. That's the word we used in class, but if the internet told you quantum, I'll let that slide. It's not wrong, but it's not what we used. On the electromagnetic spectrum, it says here blank waves have the longest wavelength, radio, while blank rays have the shortest, gamma. You should have used your chart, and you definitely could have answered that on your own. Number 3, the bending of light as it passes from one medium to another is called refraction. Alrighty. Next one, Snell's law relates to the angle of incidence and refraction using the equation Ni times the sine of theta I equals Nr times the sine of theta R. I will say if you did use the internet and you were a little confused, then some people might have N1 times the sine of theta 1 equals N2 times the sine of theta 2, which is also legit. I will give you full credit on that. Yes, sir.
It says in our notes in the particle light theory that it was proposed by Isaac Newton, but on our equation it says it's proposed by Albert Einstein.
Albert Einstein gets all the credit.
Even though Isaac Newton
Was the first one. Why? I did tell the reason why, though. I did go over this in class like a week and a half ago. No. Don't look at Chris. No, I appreciate you raising your hand. Isaac Newton, unfortunately, doesn't get credit. Albert Einstein gets the credit. Why? Say it again. How did he prove it? His experiment, the photoelectric effect. You're right. That sucks that Isaac Newton doesn't get like full credit. Like he came up with the suggestion, and his thought was, well, remember when I kept on having light where it was reflecting off of the whiteboard onto the wall? I kept doing that. Well, that was Isaac Newton's suggestion, but it wasn't until Albert Einstein came along and said, I can legit hardcore prove this with numbers and through his experiment, the photoelectric effect. Unfortunately, he gets the full credit for it. I know it sucks. It really does suck. Number 5. Number 5 over here, the correct answer is the index of refraction. The index of refraction. Hopefully you recall that. That's in our notes. That is going to be, let me go to that equation real quick so I can write it down. Our index of refraction is the N equals C over V equation. The N is going to be a value, the smallest it can be is 1, and that's light traveling through a vacuum or through air. C is the speed of light divided by the velocity of light traveling through another substance. And so N can only get bigger than 1. 1 means that it's going through a straight line. Anything bigger than 1 means that light was going through a straight line and it bent. That's what it means. Number 6, the correct answer for number 6 is focal point. The ray diagram on the concave mirror, it says here, rays of a light of a parallel, that are parallel to the principal axis reflect through the focal point. Number 7, a real image is formed by actual converging of the light rays and can be projected on a screen, while a virtual image only appears to come from a location behind the mirror or image. The next one, number 8, double check your answers. The photoelectric effect provided proof that, hey, not only that, but Einstein actually got a Nobel Prize for that. That's pretty cool. I wonder where it's at right now. Number 9, correct answer is concave lens or diverging lens is thicker on the edges and thinner in the middle, which is true, and always produces a virtual image. And then the last one, number 10, the focal point. It says here is the point of the principal axis where those rays are parallel to the axis converging after reflecting off of that. Okay, are we ready to turn the page? We need to get a little bit of math done, and then I'll leave you alone. I will post all of the answers on D2L, but I would like to pause and turn the page again. I want to look particularly at question number 5, 6, 6, and 7. One more time. I want to look specifically at 5, 6, 6, and 7 because I guarantee you they came straight out of the test. So I guarantee you they're going to be on the test. That's the only reason why I want to look at those first. It says, and I will put everything on D2L. It says, look at this drawing over here. Now, this extra thick line is showing you that light is traveling from one substance, which is, I don't have a clue, but light is traveling from here, and it's going into this. This would be number 1, and this would be number 2. Or we can call it I, and we can call this R. I means that it's going in, R means that it's refracting or bending, if that makes sense. So they gave us our stuff. When we have light traveling through 2 different substances and they give us 2 different thetas, we are going to use Snell's law. One more time. When light is traveling through 2 different substances and they give us 2 different thetas, we need to use Snell's law, and we need to make sure our calculator is in the correct mode. So for this situation, Snell's law is going to be, my mind just went blank, Ni times the sine of theta I equals Nr or N2, however you want to call it, times the sine of theta R or theta 2. For this situation, I just showed you this is part 1 and this is part 2. So this would be 2.6, multiply it by the sine of 35 degrees equals, well, this right here, I do not know it, Nr or N2, whatever you want to call it, multiplied by the sine of 75 degrees. Okay? Obviously, we want to figure out what this N number is. It's going to be like a regular number, right? It's going to, look at the one above it. It's 2.6. It's going to be, I don't know, 1.3, 2.1. It's going to be just a regular number. It definitely cannot be less than 1. We know that. N can never be less than 1. So if you get that type of an answer, then there's definitely going to be a problem. Alrighty? So if I algebraically divide this side by the sine of 75 degrees, I can cancel that out. The sine of 75 degrees. Now for this situation, handy dandy calculator. Let me double check. The sine of 35. Nope. I'm not in the right mode. Let's see. Degree. Clear. Alrighty. Now we can do this. The sine of 35, multiply it by 2.6. Nope. I'm still in the wrong mode, aren't I? Yep. Oops. Why am I going enter? Now clear it. The sine of 35 equals, multiply that by 2.6, divide it by the sine of 75. There you go, 1.54. 1.54. So 1.54. Identify using these charts over here. Do you see 1.54 or something similar to it? I sure do. Salt. Salt. Write it down. If you don't know, then write the word unknown. Yes, sir.
Doesn't it say 1.544?
Mm-hmm.
Didn't that make it
1.5.
sodium chloride?
Where?
On
The table below it? Oh, yeah, absolutely. The table below it, 1.544. And guess what? Sodium chloride is, from chemistry class, salt. Sodium chloride, same thing. Yep, absolutely. Table salt, sodium chloride, an ionic bond. All right, negative and a positive bond that crisscrosses. Oh man, remember that one? Yes. Let's do this again though. But for this one over here, it actually says that a ray of light passes through a boundary between air and an unknown substance. The ray slows down to the speed of, okay, so they told me that it was going from air, which is 3 times 10 to the 8th power, through this. What is the index of refraction? Question mark N. Or N equals, do you remember we wrote that down in our notes? If not, it was over here, C over V. C is the speed of light, but they did tell me that was passing through air, which is also the speed of light number. So I would get 3 times 10 to the 8th power over 1.95 times 10 to the 8th power. You remember your math skills? The cool thing here is that these numbers over here, the times 10 to the 8th power, could actually get canceled out. That's pretty cool. So for this situation, 3 divided by 1.95, there you go, 1.54 again, pretty much. N equals 1.54 or 1.38, however you want to call it. Pretty close to 1.54. All righty. Then it says, use both charts. Again, you can call it salt or sodium chloride, which is the same thing. Okay, same thing. The last one over here, again, like I said, you are definitely going to see these questions again. I want to make sure that I do every step with you. I will post a blank quiz, or the quiz is already there. If not, I'll post another blank one. Light is in air, and it strikes a flat surface at an angle of incidence of 45 degrees. Light is going through air, which N is 1. This is going to be Ni right there, 45 degrees. It is refracted at the other angle, or in the inside of this liquid. And this liquid, it says here, is at a 30-degree angle. Calculate the index of refraction and check out both charts. Do you think it actually is a substance? Is it something? Well, this is going to be Snell's law. N-I-S, the sine of theta I equals NR times the sine of theta R. Or 1 times the sine of 45 degrees equals, I don't know this one, that's an unknown, times the sine of 30 degrees. Again, algebraically, I would go ahead and divide this side by the sine of 30, cancel, divide this side by the sine of 30 degrees. I'll come over here, we can calculate that. The sine times 1 is going to be itself, so the sine of 45 degrees divided by the sine of 30 degrees, that's going to end up being 1.414. NR, or N2, is 1.414. 1.414, truly, I think if I recall correctly, that is considered to be unknown. Do you see it on the chart, Mr. Noah? I don't think so. I don't think it's on the chart. I think it's unknown. But double check me, because I don't see that number on the chart. Alrighty. Or on this chart either. 1.414. Nope. I don't see it on the chart. But that's how I got that answer. So I just wanted to go over it with you. Turn the page. The next question is also on the test. Guarantee. So I want to look at this one, and then we'll be done, and I'll leave us alone for the day. Okay? Here we go. First thing is, light is going in through this. They have this right here as considered to be air. So when you see a picture tomorrow, that's air. This is going to be something, I don't have a clue, that's thicker than air. Let's call it that. This can be water, and this can be Kool-Aid. I don't know. I just know that the top substance is thinner and the bottom substance is thicker. Now, when light goes from a thinner to a thicker substance and it refracts, the thicker it is, the more it's going to bend towards the normal. One more time. The thicker the substance is, the more it will bend towards the normal. Which refracted ray has the highest index of refraction? I don't know the N numbers, but I do know that this one is bent closer to the normal, so letter A is going to have the highest index of refraction. Which refracted ray has the largest N number? A. And which one is moving the slowest? Remember, when it becomes thicker, you slow down. When you slow down, you move closer to the normal. Which one is moving the fastest? Letter C. And which one has the smallest N number? Letter C. But remember, your N number can never be less than 1. 1 is the lowest number we can have. The other answers I will post on D2.